The topic which I am going to present is graphene. Graphene is a future material. What is graphene? The introduction of graphene is graphene is a single layer of carbon atoms which are densely packed in a hexagonal honeycomb lattice. It's a two-dimensional material which is atomically thin and crystallographically perfect film of graphite carbon. Discovery of graphene is considered to be the landmark achievement in the field of material sciences. Being a two-dimensional material gives it a unique set of properties such as it is the world's strongest material, harder than diamond and about 300 times stronger than steel. Next we move on to see the need of the material. Almost all new discoveries in science and technology are based upon materials. The development of new materials can lead to the uncovering of entirely new fields of research. Essentially, this also leads to new solutions to problems that may have been thought to be impossible to decipher in years gone by. Before the discovery of graphene, a two-dimensional material was supposed to be a theoretical fantasy. Graphene allows designing of compact and lightweight devices because of high surface area to volume ratio. It has extraordinary thermal, electrical and mechanical properties and has relatively low cost than other materials. Historical development. Yeah. The term graphene was first used in 1987 to describe a single layer of graphite. The concept had been around since 1947. Many scientists were looking for graphene using complex experiments, but first crystals of graphene were discovered in 2004 using an effective method, mainly an ordinary Scotch tape. During one of the experiments in Manchester, the scientists Andre Geim and Konstantin Novoselov noticed small parts of graphene on the tape, which was used to clean a graphite stone. Both the scientists were awarded Nobel Prize in 2010 in Sweden for the discovery of graphene. And thus, Scotch tape method made it possible to obtain and study monolayers of graphene. Next we move on to see how graphene can be prepared. Graphene can be prepared obviously in the one mainly used method and which led to the discovery of graphene, the Scotch tape method. The other methods include the chemical vapor deposition method and thermal decomposition of silicon carbide, reduction of graphite oxide and epitaxial growth on electrically insulating surfaces like silicon carbide. Microstructural features. The microstructural features of graphene in different structures are three-dimensional in graphite crystals, two-dimensional in a single layer, one-dimensional in nanotubes, and zero-dimensional in buckyballs. And this figure represents different structures: buckyballs, nanotubes, and graphite crystals. Graphene is zero-dimensional in buckyballs and, as I mentioned, one-dimensional in nanotubes and three-dimensional in graphite crystals. Carbon-carbon bond length in graphene is 0.142 nanometer and the layer thickness of graphene is from 0.35 to 1 nanometer. Next we move on to see the material properties. As discussed earlier in the introduction, it is the world's strongest material and about 300 times stronger than steel and harder than diamond. It is a transparent material and it is a material which conducts electricity much better than copper, and it is easily bendable and can be given any form. Yeah. And next we see the applications of graphene. Graphene finds its applications in aerospace industry, in automotive, in electronics such as for building transistors, and in communications for such as the mobile phones, and for gas sensors, solar cells, energy storage, for example the batteries, and graphene based nanocomposites, and for hydrogen storage tanks as well. There are some applications of graphene which are still under development, and a lot of research work is being done on those developments, such as the applications of graphene under development, the transistors that operate at high frequency. A high frequency transistor can be built with graphene because electrons move at higher speed in graphene than in silicon. And there is one more application of graphene which is still under development, is in the storing hydrogen for fuel cell powered cars. A fuel tank made of graphene material allows more quantity of hydrogen to store in it because of the increased binding energy, and as well as the lighter weight of the fuel tank. And this could help in the development of practical hydrogen fueled cars. Yeah. This is all about the material graphene, and thanks for your attention.